Hello everyone, my name is Peiyu from Zhongyuan University of Technology. Thank you very much for giving me this opportunity to present our recent research work at this year conference. Our research focuses on access control of social networks and has made some progress. Next, I'll begin to introduce the access control of social networks and its research status, and then I will focus on a series of solutions we put forward for the current situation, namely the personal preference analysis mechanism, the generation of access control permission list, the generation method of access control strategy, and experimental analysis. Online social network can provide digital users with social interaction and information sharing, but it has privacy security problems. The overwhelming user information can be collected by the army by illegal means, and data association can be used to infer some more private user information, which threatens the personal and property security of users. However, few users realize that privacy leakage will cause serious harm to them, and with the continuous development of data mining technology, user data is easier to be stolen. Therefore, the research of and discussion on what kind of access control of social network can better protect the privacy of user data has gradually become the focus of people. Access control is one of the key strategies to realize network security provision, privacy protection, and information security. The formulation of access control policies is affected by many factors, such as the relationship between users, and resources, and the relationship between resources and resources. However, the social graph of social networks is relatively complex, and the requirements of privacy protection and information security are different from the single system faced by the privacy access control model. A large amount of data and behaviors are dynamically changing. Generally speaking, the following four kinds of access control technologies are used in most social network access control technologies, which are based on new technologies such as relationship cryptographic algorithm, game theory, and face recognition. The traditional access control of social networks ignores the user's personal preference, which makes the user's privacy that cannot be protected in a personalized way. In this paper, a personal preference analysis mechanism is proposed. The access control policy can be made according to users' historical access control records, published network resource, social relations, and users' personal preference. The model is treated by SVM algorithm, and finally, the user access rights list is obtained. In social networks, the information uploaded by users to social networks contains different levels of privacy information, which requires different access control strategies. This graph represents the specific technical roots of the personal privacy analysis mechanism. Firstly, information entropy is used to describe the privacy information contained in the information to determine the degree of privacy of the information and to build the basic information sensitivity measurement model. Based on this model, the user's personality difference influence on the degree of privacy. Based on the social networks, users have uploaded information set access control strategies by history date. Using the arctangent function for the user uploaded social networks, users of information sharing degree of formalization. Through the analysis of the measured of the existing privacy combining information entropy, weighted information entropy, conditional information entropy, and other technology to measure the impact of user preference on the degree of information privacy. On this basis, an information entropy model with personal preference is designed. And finally, the user preference analysis mechanism for social networks is constructed. Firstly, the basic information-sensitive measurement model should be contrasted. Specifically, XI denotes the artist message posted by a social network user. PXI denotes the proportion of the amount of private information contained in the artist message to the amount of all the user's private information, and the source of information that user post information in the social networks is represented by the following Formula 1. The entropy of the source of the published information is called Hx, which represents the average private amount of information released by users in social network, where n re- where n represents the total amount of information released by users. On the basis of this model, the influence of users' personality difference on the degree of privacy is studied. Specifically, Xi denotes the artist message posted by the user in the social network. F denotes the number of friends the user has in the social network. FAI denotes the number of allowed visible friends set when the user uploads the artist message. So WF is the user's social breadth function. HI denotes the degree of confidence of the artist message. It denotes the ratio of the number of friends allowed to view the artist message Xi to the total number of friends of the user. The greater of the number of friends allowed to view, the lower the degree of confidence of the information. Si denotes the sharing degree of the artist message. This is used to describe the number of friends F of a user and the influence of the number of friends FAI allowed to be seen in the access control policy on the sharing degree of the information Xi. Two more friends a user has and the more friends they are allowed to view, the higher the sharing degree of information Xi, and vice versa. And then the sharing space of information released by users is represented by the following Formula 6. Hx denotes source in entropy with personal preference. It describes the influence of different user preference on the privacy degree of information published in social networks by sharing degree Si, and realize the analysis and measurement of user preference. The next step is to generate the list of access control privileges for the user. This diagram represents the overall architecture of the access control model based on user preference. When users publish user resources, they first make resource request and access control request for user resources and access control module request respectively. The user resource responds after receiving the request, and the user's historical access control records and social network relationships are analyzed to form user access control attributes. and then user user resources are taken as input to conduct conduct user preference analysis and obtain user preference values, and then analyze all user resources and their access control policy records and get all user resource attribute. When the access control evaluation module receives the user resource attribute, all user resource attribute and user preference value, it generates the user resource access control policy and returns the access permission list to the user after responding to the user's access control request. Finally, the user determines the resource access control rights through the result of the permission list. So, how do we generate access control policies? We pre-process the data with the user's historical resource record, friend relationship graph, and user preference value obtained through preference analysis mechanism in the social network platform, and divided the processed data into data set and test set, thus avoiding the overfitting problem. After that, the training set will generate the model through machine learning algorithm, and the prediction model will be generated through the test set. Finally, the resources to be processed will be into as the model, so as to get the access rights list of the user's resources at time. The authors research group has developed its own information sharing system with functions such as instant messaging and information release in social networks. The system is open to use in the institute. A total of 12,000 pieces of basic data were generated by 60 research subjects in the system, which constituted the dataset of the experiment in this paper, which basic data is pre-processed to obtain a five-dimensional vector eigenvalue and a Boolean target value, which correspond to the training data. 12,000 training data after processing constitute the training sample set. Species of data information contains friend ID, relationship, content ID, and so on. In this experiment, SVM algorithm is used to build the model in order to verify the effectiveness of the personal preference analysis mechanism posed by the author. The SVM algorithm is used to contrast two models, one model with the personal preference analysis mechanism. The other model did not. Compare the performance of the two models. When comparing results, the index of model performance is accuracy. TP represents the number of people a system recommends to be visible, and the user settings are also visible. FP represents the number of people whose user settings are not visible, but whose system settings are. The dataset of this experiment is treated by processing solutions. When SVM is used for data training, BRF function is selected. Constant C is used to balance training error, and gamma is used for BRF kernel function in machine learning process. After grid search optimization, the values of the optimal perimeters C and gamma are 2 to the 10th and 2 to the 0. It can be clearly seen from the graph that when the number of folds of cross-validation is 10, the SVM model with the personal preference analysis mechanism is the most accurate. With the increase of the number of folds, the accuracy will increase and decrease, but 10 folds cross validation is the best. However, the SVM model without the personal preference analysis mechanism, no matter how manifold, is not as good as the SVM model with the personal preference analysis mechanism. The graph shows the area and curve image. What we know is that this model is optimal if the AUC value is clear to 1. We can see that the AUC value of the SVM model with the personal preference analysis mechanism added is better. Through program calculation, the AUC value of the SVM model with the personal preference analysis mechanism is 0.9599. Another SVM model is 0.9518. So the SVM model with the personal preference analysis mechanism is the optimal one. Through experiments, it has been proved that addition of personal preference analysis mechanism can automatically generate appropriate access control strategies to meet the potential privacy needs of different users, so as to adapt to the more dynamic social behaviors and complex social relationships in today's society. That's the content of my speech. Thank you very much for your patience in listening to my rather long presentation.